So the last thing that we talked about was how to prove triangles are congruent either using side, 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 or side, angle, side. What we're going to look at today is 3 other options. So when you look here, notice again, guys, math people, we are not creative. All right, we're not trying to hide anything from you guys. So when you see something labeled as angle, side, angle, or ASA, the key is you need 2 angles. And notice that that side is located between those 2 angles. So if I were to take and draw a picture, I've got 2 congruent angles. So there's one pair. We've got another pair of congruent angles. And again, the key is that side has to be between the angles. So if I go from this angle to this angle, the side that I just went over is that side. Same thing here. So when I look at this, I've got triangle ABC, and then DEF, and again, it does not matter how you label or write down the first one, as long as you do your corresponding parts. So A is marked the same as F, B is marked the same as D, and then this is E. And so those 2 would be congruent by angle, side, angle. So again, the key there is that the side has to be included or between those 2 angles. If you look at the next one, the key is, if you notice here, your side is not between the 2 angles. So if you look, if you look at these 2 pictures, we've got the 2 angles marked, and you've got the 2 sides marked, or excuse me, 2 angles marked, and then you have a side. It cannot be between those 2, otherwise it would be angle, side, angle, but it has to be corresponding. So like, for example, this one, I just marked coming off of the side, or the angle marked with 1 arc. So that means it has to be that one. It can't be the bottom side. And again, I would go ahead and I can label these to do our congruent statement. So I've got triangle ABC is congruent to triangle, and that was an F there. Triangle A corresponds with D, B corresponds with F, and then we have E, and that is by angle, angle, side. So with angle, side, angle, your side has to be between those 2 angles. For angle, angle, side, it's not between them, but it is a corresponding non-included side. Okay, we're going to do plenty of examples, so don't stress. When we look at this, it says, what combinations of angles and sides have we not discussed? So first off, if you think about side, 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 we've done that one. If you think about side, angle, side, we have done that one. If we do angle, side, angle, those are the ones that we just are looking at today. Angle, angle, side. These are all ones that we've done, so I'm just going to put a yes here. The ones that we have not done, angle, angle, angle. Now, if you think about an equilateral triangle, all of those angles in an equilateral triangle are 60 degrees. You could have a teeny tiny equilateral triangle, all 60-degree angles, and a huge equilateral triangle, again, all 60-degree angles, and those 2 triangles are not congruent, because if you think about it, teeny tiny one, big one, they're not the same size, and to be congruent, they have to be the same size and the same shape. So this one is a no-go. We're never going to use angle, angle, angle to prove triangles are congruent. The other option that we have is this pattern, okay? Now, think about what this says backwards. If you ever write this word backwards on a math paper, you know that that's a no-go. We cannot do it. You cannot do it this way either. You cannot do SSA or ASS. So let me go ahead and click this real quick, see if we can get this to open. Hold on one second. Let's try this. Maybe. It's not going to let me do it. Okay, it's loading. It's loading. Sorry for that little delay, guys. You can see on my little spinner, it's thinking about loading. Maybe not. Okay, so let's take a look at this example. So this is a little website that I have to help kind of describe this. So if you notice, you've got a side congruent to a side here. Same thing, you have another pair, and then you have an angle down here. So this is a case where you have side, side, angle. Notice that if we look at those, it would match side, side, angle, but if you look at those triangles as a whole, those are clearly not congruent triangles. This triangle here on the right is an obtuse triangle because of that spot. Now, here's the thing. if I were to take, I can rotate that side outward. And so it could be congruent, but we're not guaranteed congruency. The only thing that would work, notice as I keep tapping this, it's going back and forth. The only thing that would work is if I were to take and drop this segment straight down the middle instead of this. And if I do that, then all of a sudden I have a right triangle. And so instead, I'm just going to kind of highlight this in here, I would have a leg and I would have the hypotenuse. And so that's the only case in which that SSA could work. Now, we still don't call it SSA. You will never write SSA. You will never write ASS. However, you could have a situation in which you're using a right triangle and you're going to have the opportunity to use HL. So notice it only works with right triangles. If you do not have a right triangle, you cannot use HL. With that being said, if you have a right triangle, it does not automatically mean that you can use HL, okay? It means you could. It doesn't mean that it's 100% for certain. So here's the deal. Let me show you what this would look like. So you've got the right angle, so you know HL is a possibility. Then you have a leg that's marked. Then you have the hypotenuse that's marked. If that's the case, you can prove that those two triangles are congruent by HL. So you would have something like A, B, C, and then D, E, F again. So you'd have triangle ABC is congruent to triangle. A corresponds with F, B corresponds with D, and then we have E, and you would say that by HL. Again, you could only use it with a right triangle, but if it's a right triangle, it does not automatically mean HL. All right? So let's take a look at these examples. So you've got an angle, and a side. Okay, same thing here, an angle, and a side. Notice that side is not in between them, so they are congruent by angle, side. If we look to the right, we've got SSA. You're asking yourself, is the angle between the sides? If it is, it's an SAS, but it's not. Okay, in order for it to be between the sides, it would need to be this angle. It's not, so this would be not congruent, and again, that's because you cannot use SSA. That does not work. If we look at this picture, don't be fooled. You have an angle that's a right angle, but that doesn't mean that it's automatically HL. Instead, look at what else is marked. So your side is between those two angles, so ASA works. This one on the right, you've got that reflexive property in the middle again. So you've got angle, and then the side in between. Okay, notice when we look at this triangle, this one is one that tricks people because this side is between two angles, but it's not between two angles within the same picture. So what I mean by that is if I look here, within the same triangle, that side is not between those two angles. So that's why it has to be angle, side. For the last one here, you've got two sides, you got the angle in between, so you can use side, angle, side for that particular one. So today what you're going to be looking at is more examples with this. Reminder, reflexive property, you can automatically mark. Vertical angles, you can automatically say that they're congruent. Okay, when we're doing the proofs, we're going to state that. But for now, you automatically know those are congruent pieces. Okay? As always, ask questions. Hopefully we're starting to see patterns and starting to get a little bit better at these things. Thanks, guys.